Hi guys. So I hope you people are preparing really hard for your exams. Okay, so here we are with discriminant. This is the next segment that I had spoken about, quadratic equation, right? So this segment is really very important and there are many questions based on discriminants. Okay, why so? Because as you can see, a discriminant in a quadratic equation is used to determine the nature of roots. Roots as in the value of x's. Okay, we have, say this is a quadratic equation, x square plus 5x plus 6 equals to 0. Since there is an equal sign over here, so it's an equation. Since there is a power of 2, which is the highest power of this polynomial, okay, so we call it a quadratic polynomial. So this together is a quadratic equation. All right. Now, discriminant will tell you what kind of, okay, roots we are going to call, okay, them like. So roots are also given names, okay, because this is quadratic. So we stick to alpha and beta. So alpha is the first root and beta is the second root. All right. Now, if in place of x square, if there would have been a cubic polynomial, so in that case, it would go to alpha, beta and gamma. Well, now we have to concentrate only on quadratic equation. So let's get started. So what they are trying to say is that what kind of nature of roots shall we get if we use this formula D. Big D is referred to the discriminant and which is equal to b square minus 4ac. Now b square minus 4ac, you must be wondering where did b come from, unless you have watched my previous videos, okay, where I have given you all the details. But I can just go through once again for those who haven't ventured those videos of mine in the playlist. So b square, we derive our a, b and c from here. The coefficient of x square is equal to a. Coefficient of x is called the b and the constant over here is known as c. Alright. Now since we know that d is equal to b square minus 4ac, okay, so my b square in this case is 5, a positive 5, okay, so 5 square minus 4 is already a constant. It hasn't come from anywhere, okay, it will be there. This is the formula. A is my 1. Whenever they don't show any coefficient, okay, it means that it is equal to 1. So we have 1 as A and for C we have 6. Correct? When 5 is squared, we get 25 and 4 into 6 is 24. So 25 minus 24 is equal to 1. Now we know that 1 is greater than 0, isn't it? Which means D, if it is equal to 1, so D is greater than 0. Okay? And the cases where D is greater than 0, we can say that the roots will be real and distinct. Distinct as in different, non-repeating. Okay? So real means it will find a place on the number line. It is very much real. These numbers are not imaginary, they are real. You will find them, okay, a place on the number line. They could be whole numbers, okay, natural numbers, integers, rational numbers, irrational numbers, but they will be, okay, all referred to as real. So for example, if we were to solve this, we would get some value for 2x's here in terms of alpha and beta. To find the roots, okay, we will have to use either the quadratic formula here, alpha, you get it like this. For beta, you use this. D, you already know, it's b squared minus 4ac. So this is D. This D is same as this, which is equal to this, okay? As we have solved over here, so this will go to fit in here. Since we have got 1 over here, so I'll write 1 here. And minus B, okay? Which means, okay, minus 5. Alright? And for A, we'll write 6. Well, this is how you solve a quadratic formula, which have already been discussed in the previous videos. So I'm not getting into that. Here I am to tell you how to find the nature of roots, which is very, very important from exam perspective. Alright guys. So roots are real and equal. Can you see it? Remember, this is not equal, this is unequal. It's distinct. It is one, okay, of, okay, different kinds. Here it's equal. They are like mirror image. They are same, okay. You can call this repeating. If alpha and beta would be same, we would call them as equal roots. If alpha were to be 3 and beta also 3, I would call them equal. If alpha would be 6 and beta 6, or say if alpha were to be minus 13 and beta were to be minus 13, I would call them as equal roots. But if alpha was 2 and beta 1, I would call it distinct. If alpha was minus 5 and beta was say 3, I would call them still distinct, non-repeating. So there are various ways of calling them, correct? So now you know two things, that roots will be real and roots will be real when D will be greater than 0 or D will be equal to 0. So in both the cases we have real roots, very much real numbers, correct? That is why we say, okay, adding up these two, we say that when D is greater or equal to 0, we know that roots are real. Correct? So this is, okay, a blend of these two. This is quite important, okay, because sometimes they will give you questions, they might give you MCQs, okay, and ask you to find out, okay, which of them have got real roots. Okay, so in that case, please don't use this or this. Use this one because both of them have got real roots. So it will be best if we found out if the discriminant was greater than 0 or if the discriminant was equal to 0. So in both the cases we would claim that it has got real roots. But if they tell you that which of the MCQ has got real and equal roots, then you would see to it that if your D is coming equal to 0, it will mean that your roots will be not only real but equal to. Equal can be also said repetitive. As I said, if this were 3 and this also 3, I would say that they are repeating. They are same. Okay. So this is very important. Okay. And they can confuse you if you do not understand well. So if you will go and write only for this, okay, that this is real and forget completely about this, then I am sorry, that will cause, okay, a problem for you. So please be cautious, and I'm sure you will understand this. Okay, so wherever there is, okay, d either greater than or equal to 0, you must know that roots will be, means alpha and beta will be real. Now, having said that, there will be, okay, in this several categories of roots. They will be real. In common, they will be real, but they can also be distinct. They can also be equal. Okay, so either this kind or this kind, so that you have to see, okay, all over again whether the discrimination is equal to 0 or not. All right, so now last thing that you have to understand is that when you calculate it, say in this case we are calculating d, so we know that b squared minus 4ac equals to discriminant. So, okay, b in this case is 4, so 4 square. 4 is constant, okay. So we bring down 4. A is 1 here and c is 5 here. So 4 into 5 is 20 and 4 square is 16. As a result, d is coming as a negative 4. Now negative 4, okay, is always smaller than, okay, 0. Which means automatically d is what? D is smaller than 0. And as soon as you find that out, you would know immediately there is no real root. Okay, such roots are called imaginary also. Alright, about them you will be learning much more in detail in higher classes. Okay, associated with complex number. Okay, so for now, if I have to sum up quickly in 1 or 2 minutes, I would say discriminant is the one that decides what kind of root it is. Okay, so what kind of roots would be there in a quadratic equation? Quadratic equation, whether they will be real or not real, whether they will be real, okay, and different, or real and equal. Okay, and having said that, okay, you will immediately have to calculate discriminant. You can't see and say it. By observation, you can't do it until you're very clever in mental maths, correct? So if you do that, okay, then only you come to a certain point where d is calculated and you see it whether it is greater than 0, equal to 0, or less than 0. So only these three, okay, kinds of discriminant you will find, which is going to discriminate different kinds of roots or the nature of roots. So I hope this is clear to you. Okay, in case you still have any doubt, please do write in the comment section. So I hope your exams go well. I'm coming up next with the concept of sum and product of roots, and then formation of quadratic equation. So those all will end up the quadratic equation chapter. Okay, so this is it. So all the best for your exam. So bye bye for now. Take care.